Hello, everyone. My name is Marijan Jozic, and I'm from the company Octonix, which is European affiliate of SAE ITC, Industry Technology Consortia. Our guest today is Mr. John Tintinalli. Mr. John Tintinalli is General Manager Europe for SAE International. He's also a board member of IAMTS. In short, we have one very interesting guest today. Coming up. Hello, John. So, how are you today at this sunny Dutch day?
Well, it's sunny, but true to Dutch days, it's also extremely windy. So, and the clouds keep coming through, so you never know if it's going to be nice or it's going to be miserable.
Okay, it is typical Dutch. It's,
Typical
uh,
Dutch.
it's changing every 10 minutes.
Not even. Yeah.
Yeah. Well, welcome to the podcast. This IMTS podcast. That will be number 4 already. Our last guest was Mr. Alex Kraus, and I will tell you later on what is his question because we have the fast. We have a question which is that in Netherlands they call it chain question. So every time when you have podcast, I ask person to ask question for a next person in the podcast. So we'll come to that. But first,
Oh, okay.
that is just to think about that. What will be your next question? And I will tell you what is next guest. Next guest will be Herman Brandt. So you can already start
Oh,
to think
Herman.
about, yeah, Herman.
Well,
You can
he's one of my favorite people, so that's good.
so you can already now start to think about question for Herman, and I always say make the question so difficult that he have to sweat and do some research to answer it.
Mm.
Let's start with my first question. But there was my question was what I always wanted to ask, but I was always afraid to ask you. What brought you in automotive industry?
An accident of birth. Um, I was born and raised in Detroit, actually downtown, which is pretty unusual, especially back then. And coming from Detroit, I would say a great proportion of families had at least somebody in automotive, working for one of the suppliers, working for what we called the big three OEMs, GM, Ford, Chrysler, were somehow affiliated with them. Um, Although I began my career in the startup world in software, an opportunity was presented to me with another startup that was developing um, a kind of a software as a service and other service oriented business for automotive shipping and expedite, basically shipping parts from one plant to another plant when just in time fails. That's what expedite is. So, and I did that for a number of years. So that gave me a lot of exposure to the automotive industry and working with OEMs and suppliers and the whole supply chain. And that company at the time was called National Logistics Management. Since bought out and bought out again and ended up in the hands of XPO. And then I did some consulting after that, did some projects for GM, did some projects for BMW, all kind of software related, logistics related. Um, then I went into healthcare for a while because, believe it or not, healthcare was quite behind in terms of processes and technology. And so took a lot of what I had learned from the automotive space to apply that to the healthcare space for a period of time. And but then ended up back in automotive, and it's where I like to be. I like the culture. I like the people. I love cars. So I'm here to stay.
Yeah, that's interesting. And especially it's interesting that there is something parallel with the automotive industry, and I would never say it is healthcare, and that you could switch easily to healthcare, and probably there is a lot of logistic in healthcare too, and processes, procedures. So that's quite interesting. You would thought
And
automotive industry has much more common ground with aerospace or with trains and rails because that all is moving. But healthcare, okay, that's interesting.
yeah, no, it was fun for a time. It was.
Uh-huh. And then you landed at SAE International. Can
I
you say
did,
a few
and
words about SAE International for our listeners? What
so
they
in
do and how do you like them?
yes, of course. Well, I've been working for SAE International for over 7 years now. So I really do like working for that organization very much. It's a nonprofit, so it means there are no shareholders, and we have a public service mission. And that public service mission is to advance mobility for the benefit of mankind. And we do that through things like safety, interoperability, sustainability. Work on all these things as part of the things that SAE does. We started back in 1905, founded by Henry Ford, and later added aeronautics um, by the hands of Orville Wright, of the brothers Orville and Wilbur Wright, in 1916. Of course, aeronautics later expanded to become aerospace when we started venturing beyond our atmosphere. And we're an association of individual members, not companies. So it's an association of individual engineers in what is now termed mobility. But it's open to all. You don't have to be an SAE International member to participate in our open standards processes or events or anything like that. So we end up with about 200,000 volunteers globally. We're headquartered in the United States in Pittsburgh, but we are a global organization with a global constituency of volunteers and other stakeholders. And we do all kinds of things, events, tons of training on the professional level. We train young engineers in new areas. We train experienced engineers in new areas to help them advance their careers. We work on the collegiate level and what are called collegiate competitions, or we call the collegiate design series. So things like Formula, Baja, that sort of thing. We do also a lot of STEM education. So it's science, technology, engineering, math to encourage children to become interested in engineering, hopefully go into that at the collegiate level. That's part of our mission-based work. And we produce a lot of technical papers that are all peer-reviewed and journals and books. That's all part of our mission.
Yeah. Isn't it interesting that you mentioned the Wright brothers in 1916, or it was quite some time ago, and then because they were bicycle makers, and after so many years, we are now returning to bicycle projects, vulnerable vehicles, and trying to protect bikers on the roads. That's
Uh, that's
that's
funny that you mentioned that. I just sent an article, well, from here in the Netherlands, where I live and you live,
yeah,
to our colleague in Silicon Valley by the name of Pooja, who runs our micro mobility community committee,
yeah,
about the new proposed Dutch initiative to enforce speed limits of e-bikes on Dutch pathways here, which, as you know, is a problem.
yeah. I've
So,
heard that
yeah,
yesterday was at the news that they want to limit it in Amsterdam to 20 kilometers per hour, which is just a normal bike with can reach that speed. So it is quite interesting development here in Netherlands.
I think it's a pretty reasonable request.
Yeah.
Yeah, it's gotten a bit out of hand.
Well, the people are scared of that. They say, "Oh, they're trying to limit our rights." But if you look how many accidents are happening every year in micromobility, all those vulnerable vehicles, bicycles, and all those slow traffic, then that is scary. How many accidents, how many people are killed. So we should do something to limit that. Yeah. And your role as European director at SAE, what is your role here in Europe?
So I'm the general manager for SAE International in Europe, and we have an entity called SAE Europe here. I'm the general manager for that specifically. I'm responsible for supporting, evolving, and managing the stakeholders of mobility here in Europe. We have over 4,000 members, so those are active paying members of SAE International in Europe. And we have over 3,000 people, these are expert engineers, participating in our standards committees, who may or may not be members, because again, it's an open forum that SAE provides for standards participation. So that's a lot of people to support. We have sections in Italy, we have a section in Northern Italy, we have a section in Southern Italy that are both made up of members, primarily academics who publish a lot of papers and journals. We're developing a new section in the German-speaking regions. So that's the DACH section. So Germany, Austria, Switzerland. And we have a lot of cooperative agreements with other organizations here in Europe. So I'm working on furthering those relationships and those partnerships.
Well, at a certain moment in your activities, you was involved in IAMTS. How that happened? Because you have some history with IAMTS.
Yeah, I was one of the co-founders of IAMTS. And as many things happen in life, there's a bit of serendipity. So first running into a guy by the name of Joachim Teiber, who had really conceived of this a number of years ago. He was CTO for a test track down in South Carolina, not far from where I used to live in Greenville, near the BMW plant there, when I was doing work for that. And he conceived an idea of bringing test beds, or test tracks, if you want to call them even, together to improve their capabilities for technologies such as automated vehicle testing, and sort of bring those under an association to help them improve, and then give the market of test bed users more transparency into what the capabilities of each of those test beds might be for a particular technology or use case. And then we had an SAE event down in South Carolina, and I ran into Alex Kraus, who was your last interviewee.
Yeah.
And through that, Alex and I hit it off, and we decided to really put some effort behind this. And some months later, at our SAE World Congress in Detroit, which is now called WCX, I guess because it sounds fancier, we launched IAMTS officially, and the rest is history.
Yeah, that's very interesting. So you planted a seed. That's great. Well, let's deviate a little bit from that. I would like to ask you, what do you think? What is the most important development in automotive industry? What will develop in next 2 years from SAE perspective? Where is SAE focusing now for next couple of years?
We are focusing on heavily aligning with the needs for electrification and advanced propulsion particularly with regards to sustainability and the broad commercialization of um, more sustainable propulsion. Um, doesn't doesn't do good enough that we might have, say, 10% of electric vehicles, 10% of vehicles being electric on the road. It's not going to make enough of a dent in our climate change goals. So we've got to get that number up. And so we're working on some of the challenges that industry faces to increase those numbers. And those challenges are things like charging reliability. Believe it or not, 30% of charging station transactions fail for one reason or another.
30% is quite a lot.
It's quite a lot. It is quite a lot. And you imagine putting a lot more vehicles on the road, a lot more charging stations. Well, you're wasting a lot of time and money and creating potential, lines and problems, and maybe even turning people away from purchasing electric vehicles because of that. So that has to be addressed, because then 30% of your infrastructure potentially is not being fully utilized. Another thing we're working on is in the realm of batteries, so battery life. And when I say battery life, it's not about necessarily just how long that battery lasts. That's one definition of battery life, but literally the life of that battery, where it and its components come from, how it is used, and where it goes after it's first used. So let's say battery is used in an electric vehicle, that vehicle is resold. That battery has, a certain shelf life, right? So
Yeah.
helping to figure out what that is and what ultimately that the value of that battery is, and its condition over time. And then if that battery is then taken out and used for other purposes, maybe at some point in its life, it's removed from that vehicle and it's used for energy storage, and maybe it's sent overseas. So we're working on things regarding that as well. In addition, we continue to work on things like automated vehicles and VDEX communications and advanced manufacturing, which brings in, newer and hopefully cleaner materials and lighter weight materials into the construction of aircraft and ground vehicles. That's also an area of great importance for us.
I visited that Farnborough Air Show, and they were showing the electric aircraft. And I asked what is now the biggest challenge, and they started to complain about connector. Every company what is building electric aircraft at this moment, it's just tiny little small aircraft, two-seaters. But every company has different connector to charge the battery in the aircraft. And I think that is also one of the major problems in the automotive industry. And I noticed that there is a working group trying to standardize it. Is it
Well, yeah,
such a big problem like I think that it is, or is it
it
fixable?
is. It is. And this reminds me of cell phones, right? To this day, we still have Apple using one kind of charging cord, and we have Androids using another kind of charging cord. It's gotten better because at least there are generally only two now, but I would say 5 and 10 years ago, there were many more than that. There are probably at least 10 different charging adapters. I still have a drawer full of them somewhere because you always think you might have some use for it and hate to throw that away. I'm sure we all probably have that drawer or box of old charging adapters. So I think that it's just going that way. Yes, we have actually already plenty of standards for charging adapters. There's some under ISO, there's some under SAE, there's some probably under IC. And gradually through the enforcement of the regulators primarily to make this simpler. So a vehicle or an aircraft can essentially use maybe not any charging station, but a large proportion of charging stations. that'll come down. So there's some effort. There's definitely an awareness of this being a problem. It makes everybody a little bit uneasy, but gradually, just kind of like with phone chargers, it'll get there.
Yeah. Okay. That's good. That's at least that is good news. Well, that is important to cooperate and to have all people involved in the whole industry to work together to fix those major problems.
Well,
And
I mean, here's an important thing to think of. When some people think of standards as discouraging innovation, it's just the opposite is true. Standards encourage innovation. So, we've got multiple standards for charging adapters. What are the reasons for that is, let's figure out what works best. What is the least expensive, the most durable, um, that sort of thing. And then gradually you'll probably have, one or two or maybe three winners that come out on top. And that's okay.
okay, let's move to question what is more close to IAMTS. Um, IAMTS used to be SAITC consortia. They're now in Vienna. They're separated last year. And what is from SAE point of view? What is the importance of IAMTS? Because IAMTS there are 45 members. The people are really very cooperative, attending those meetings. But from SAE point of view, where can you place the IMTS and in the whole industry, the importance of that
I think
company?
for us, so I'm speaking, on behalf of SAE International and even SAE Europe. One of the things is what I would call pre-standardization. So increasingly, as we have more rapidly changing technologies or technologies and processes that are not ready for what we call full consensus standardization. And those processes, for some of you may know, can take 2-3 years to develop, in consensus, or maybe not at all. SAE International has been looking more at what we call pre-standards. So pre-standards are things that it might be a process or recommended practice or a protocol that maybe not come to an agreement on, but a representative proportion of industry, preferably global, like IMTS, can agree upon. And that then becomes a seed for industry and product managers and even policymakers to move forward without having to wait for a full consensus standard process. So that's why we're interested in IMTS primarily. The second is it brings in a global constituency that may or may not be used to participating in activities of SAE International or other global formal standards activities. And so it exposes them to SAE International and exposes us to them. And so it becomes a valuable network as well.
Yeah, that sounds very, very, how could I say, from that stand, I was not looking at that from that standpoint of view, but it looks like a very logical step to have some kind of pre-standard group of people who isolate potential problems in the industry, which should be defined and at a later stage transfer to standards. So that's very interesting standpoint. I like that also. Yeah. Good. And let me go now to the chain question. That last time Alex Kraus was in a podcast, and I asked him, can you formulate a question for John Tintinalli? And please make it very difficult. Let him sweat to answer that question. Well,
Okay.
I guess you've heard that in last podcast. And basically what the question is, he said, well, John Tintinelli is traveling a lot around the globe, and probably he would be able to answer that question. The question was, what are the three necessary steps to enable level 4 automatic driving? How about
Oh,
that?
this is a sweater. Ooh, and I don't mean the pullover kind, the kind that makes you sweat.
Yeah,
Okay, so let me repeat the question. So the three necessary steps to enable level 4 driving. Okay, well, first of all, let's explain what level 4 is, because there may be some misconceptions
yeah,
out there. So what level 4 driving means, this is part of the SAE levels of automation under the standard J3016, um, is a vehicle system. So a vehicle and its accompanying software can operate fully automatedly without a driver and without driver intervention at all within what is called an operational design domain. So what is that? An operational design domain, or ODD? All it is a set of criteria that are defined, which could be a geographical limit, a speed limit, weather conditions, that sort of thing. So the cool thing about level 4 is you can define level 4 in any way you want. So for example, if you said, I want to have a commercial vehicle like a tractor trailer for an 18-wheel truck operate at full level 4, well, you could say that level 4 is only within, say, the parking lot of a cross dock, and it operates completely automated, autonomously without any driver within that location only, and that is fine. That defines it as level 4. If you have a shuttle that operates, say, on a university campus and only operates, for example, on specific roads, and maybe only operates when there's no snow, that also defines your operational design domain. And if it can do that fully autonomously without the intervention of a driver, that is also level 4 automation. So that gives a lot of flexibility to what level 4 can do. So rather than say, well, what do we need to do? What are the three things we need to do to enable full level 4 driving? I think what we should say is, what do we need to do to enable full level 4 driving for particular use cases or operational design domains? If you want to define your operational design domain in terms of, let's say, one of the more broad contexts that are being considered, and we consider this with sort of the shared ride services, things like Lyft or Uber, for example, operating within a certain geographical region, picking up passengers and dropping them off without a driver in the vehicle. That's sort of one of the dreams, right?
yeah,
We have to do one. We really have to improve testing, and that means a lot more virtual testing, and that also means the validation of virtual models against real life testing scenarios, and those are, done and established in a physical test bed. And we need to do that in an economical way. So that means a lot more combination testing. So some virtual and some physical. So you might have some physical models and some virtual models working together to test a system. And that's what's called a cyber physical test bed very commonly. So that needs to be accomplished. Of course, better definitions of operational design domains, ODDs, and realistic expectations for what those should be. If you try to shoot for the moon, right, in 1916. You're not going to get there until the late 1960s. So let's be realistic about what can be done and what makes sense at a commercializable level. So I say that's number two.
Well, that means that it will go little by little, because right now at level 4, I believe, if I was listening good what you was defining, those automated trucks in Rotterdam harbor who are bringing container from the ship to truck parking place, they're also automated. That could be called also level 4. Then
Certainly can.
they're doing experiments at the airports to bring with those vehicles who can bring suitcases from the airplane to the main building. Then there are also vehicles who can bring crew to certain position where airplane is parked. They're also without the driver. You can just step in and say, well, gate 45, and it will bring you to the parking place by gate 45. That is already quite advanced in development, those vehicles. So that means that we have already quite a lot of applications for level 4.
We already have level 4, right? We already have level 4 and in quite a number of scenarios. So it's about expanding those into more complex scenarios that are commercially viable.
Yeah.
Let's see. So if I have to have a third one, so those are two, and I think those are the most important. But if I have to have a third one that enables maybe those others, the AI uh, that enables automated driving, even for level 4, but certainly for the more complex ODDs within the possibilities of level 4. Those need to improve, and it was obviously much harder than many had what I consider to be naively purported some years ago. And that's going to take some more time. There's still a lot of investment in improving the AI for automated driving. That'll continue to be the case. Yeah, there's been some investment pulled, and there have been some companies that have gone under. That's natural. When markets dump a bunch of money into seeing who comes out on top and to see how viable a particular technology or innovation is. And then things will shake out for a while, and there'll be just sort of a more slower and concerted effort to move forward. And that's what's happening now.
Yeah, well, I think we are quite a lucky people that we are now at the edge of new development. I always have to think about that story from I believe 1860, when Carl Benz developed first car. At that moment, when that car started to run, there were no roads for cars, there were no petrol stations. He had to travel from pharmacy to pharmacy to buy alcohol or small portions of gasoline to fill the car. So, and maybe 20, 30 years after that, we have the whole infrastructure in many countries where all the cars were driving. And we are now at such new border of development that, there will be artificial intelligence introduced, automated driving. It's a great time to live right now, to see
In
that
some ways,
developing
in
and to
some
be
ways
part
it
of it.
is. I guess it's always better to be on this side of the dirt while we can.
Yeah. Okay. Well, that was nice conversation about all those things. But did you formulate question for Herman Brand? Because we will have next podcast with Herman. And is there something that you can ask Herman to let him have a sweat and answer the question? I guess that question was quite challenging about the automating driving, level 4 automating driving. And I'm just curious, what for question are you going to ask Herman?
Well, knowing Herman, who's a dear friend, and some of his previous work, I would ask him if some of the promised benefits of automated driving, and let's talk about reducing traffic congestion being really one of the main ones. If that's possible without cooperative systems, which would require a lot of V2V, V2X communication and coordination. And if it's not, what would be a realistic timeline for a critical mass to develop where you would have enough vehicles on the roads and enough investment in infrastructure to facilitate that type of vehicle cooperation, traffic cooperation, to actually reduce congestion? To you, Herman.
Okay, well, that is challenging question. Excellent. I'm looking forward to talk to Herman and to let him answer it for you.
Wonderful. Well, thank you very much for this opportunity. Good speaking with you, Marijan, as always.
Thank you, John, and we'll keep in touch. And thank you very much for spending time with me.
Ciao, ciao.
Thank you. Bye-bye.
Bye.